Hi, I'm Spencer Krause. I've been building robots for over 20 years. In that time, I've seen a lot of interesting things, and I've heard a lot of interesting stories. Collaborative with Spencer Krause is a place where my colleagues and I can relax, crack a drink, and talk about some of the crazier things we've seen at work and some of the experiences we've had that have gotten us to where we are today. Subscribe today to join the collaboration. Welcome to the Collaborative Podcast. I'm your host, Spencer Krause. Our guest today is Nicholas Kirsch. Nick is a director of software engineering at Omnicell. Nick, welcome to the pod.
Yeah, thank you, Spencer. Thank you for having me. Really excited to be here.
I appreciate you coming on, and I also appreciate you being a listener of the podcast. It means a lot.
Yeah, long time listener. So first time on, long time listener. Yeah.
Awesome. So, you have had a long and storied career in robotics, and you've worked at Sarcos, Iam Robotics, now you're at Omnicell. I'm sure I'm missing like a bunch of awesome pedigree there.
RE squared for 1 month, and then they were acquired by Sarcos, so we'll throw that one in there.
RE squared Robotics, one of the coolest and best robotics companies ever.
Yep.
What made you decide to go into robotics? I mean, that's not a path everyone chooses, and what was your plan B if you didn't go into robotics?
Well, honestly, in a way, robotics is kind of the plan B. So sometime during my undergraduate. So I was at University of Pittsburgh. Actually started at St. Vincent College. Went from there to University of Pittsburgh. During my time doing my bachelor's, I was acting as a TA and a tutor for some of the programs that they had there, and found that I really enjoyed teaching, right? Had a really good time doing that. And so I wanted to go on and do my PhD, right? So in my mind, it's okay, I want to teach, but I also want to work with some really cool technology as well, right? So I want to teach, I want to do research. Obviously, the path to that is going and doing a PhD, eventually getting back into academia, right? So that is the route that I had in my mind. So, didn't have a good opportunity for a PhD after finishing my bachelor's degree. So I went for a master's, trying to kind of work my way into the PhD, right?
Still at Pitt?
Still at Pitt, yeah.
Nice.
So Pitt the whole way through. So
That's
it's
awesome.
It's Pitt, bachelor's, master's, PhD.
I did my undergrad at Pitt.
Yep. Great university and very slept on for, people that are in the robotics industry in Pittsburgh. And so, yeah, I went and I did my master's, and, the plan was do a master's, work that into a PhD, find more funding, continue my PhD, right, graduate, yada, 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 go on and teach. And so while I was doing my master's and while I was doing a PhD, I continued to, teach. I was working with Investing Now and Excel, which are programs at Pitt, which are focused on actually increasing diversity in engineering.
Oh, cool.
And so
we certainly need that.
Right. And so
barely any of it.
Yeah, very little. And so I spent a lot of time with them, TAing throughout the semester and tutoring. And then in the summer, they had a really great summer program where, because I was doing my degrees in mechanical engineering, I had taught a lot of different mechanical engineering concepts. We built solar panel cars the 1 year.
I didn't know you had degrees in mechanical engineering.
Yeah, it's all mechanical, which is very confusing for a lot of people because, again, director of software engineering.
Right, and I know you as a software engineering director.
Right.
So,
right.
To your point.
So, yeah, doing mechanical engineering, teaching these concepts in the summer to, high school kids. 1 year, obviously, we decided to go and grab the Lego robot kits and teach robotics. And even my PhD, the focus was neuroprosthetics. And so we were working on two of the main applications were neuroprosthetics to restore motor function. So people that are paralyzed, we can use combinations of electrical stimulation and motors to restore functional motion to them.
Cool.
And then the other one was using it for the means of therapy. So if an individual suffered from a stroke, we can use combinations of electrical stimulation and motors to help increase the rehabilitation rate.
That's awesome. What if you just want a third arm?
Well, we didn't get into that, but it's interesting that while I was at Pitt, I did have an opportunity to take a course. So it was very focused in brain-machine interfaces. And we were taking a lot of the work that they were doing at Pitt, where they were doing brain implants with monkeys. They did the first human brain implant to control a robotic arm. We were working
Cool.
with a lot of that data, and building up these systems. So we were learning and understanding brain-machine interfaces. And so, the first person that they did this experiment with, she was actually a quadriplegic, right? Couldn't move. And so for her, it was, well, we're going to go through this. Like, what's the one thing you really want to do, right? If you had your mobility back, if you had your freedom back, what do you really want to do? She's like, I just want to eat some chocolate. Like, I want to pick up some chocolate. I want to eat it. And I remember watching all those videos where, all that hard work they put into it, the research, right? They had one of those, it's maybe not $1 million, but $1 million DARPA robot arms, right? That has full articulation in the hands. And they're doing this with a brain machine implant. So they implant the electrodes in the woman, and they eventually got it to a point where she could actually control the robot arm, right? Pick the chocolate up off the table next to her and feed herself.
Nice.
Right. And so getting back that freedom of mobility, being able to do this task for herself, right, was a really big deal. And so it was really exciting to be at Pitt during that time. And, I wasn't in that lab, but working with some of the people that actually worked on that project and learning from them. And so, we had a lot of...
was that the Hurl lab, or was that a different one?
It was not the Hurl lab. It was a different lab. Some of the work that I did with the Hurl lab was more focused on... We had grants with some of the people in the Hurl lab where we were working with the VA, and that's actually where we had our first paraplegic that came in, that we put into essentially this hybrid exoskeleton where it's a combination of motors and electrical stimulation.
Oh, cool.
And so, right, we were able to, at least during my PhD, we were able to get to the point where we had a person come in who was paraplegic, and we were able to hook him up to electrodes using electrical stimulation, and we had some extra motors because if you are a paraplegic, your muscles have atrophied.
Did you go to like EMG, EEG, some combination of both, brain implant?
No, we didn't make it that far. We were just using surface electrodes to begin with, and the problem.
I think EMG and EEG are surface, aren't they? Like you've got EEG and EMG.
Yeah, for measurement, not for stimulation though. So we were actually
interesting.
So we were using surface electrodes to
stimulate the muscle in order to be able to restore function from actual legs.
Right. Not electromyography to measure.
Okay, that makes more sense. Sorry, I misunderstood.
No, that's okay, because we looked at that as well because.
So that's what a hybrid exoskeleton. You're actually using the person's real limbs, but you're restoring a control pathway.
Right, because a paraplegic, right, they have not been using their legs, depending on the circumstances of their injury. Some of them have maybe never used their legs. Some of them haven't used them for years. The muscles have atrophied. And so you can't expect someone who hasn't been walking for years to get up and walk.
Yeah,
right?
makes
no
sense.
matter what you're doing from an electrical stimulation perspective, they just don't have the muscles to do it.
Yeah, makes sense.
And so
how do you overcome that? You just have to exercise for like months in order to recover muscle and then do it?
Yeah, and that's part of the advantage of using electrical stimulation, right, is that they're building back up that muscle mass. It's increasing circulation to the legs. It helps with all sorts of...
So you're just like 2 hertz, like just go.
Yeah, it's a little more than 2 hertz, but so we're using that electrical stimulation to get the muscles to cause a lot of the motion, but then we're also supplementing that with electrical motors.
What are like the voltages and currents involved in doing something like that, and like the frequencies? Like, I mean, just being a nerd, like I'm curious.
Yeah, and I'm trying to remember all the details because that was a really big thing. And
what are your controls? Like, how do you modulate amplitude of like muscle response?
Yeah, and there's more than one way to do it. You could just think of it in terms of power, right? So I want to put a certain amount of power into the muscles, and I could either control that power just by controlling the amplitude, or I could do something like pulse width modulation, right? And so
But either way, that's controlling voltage, I would think.
Mm-hmm.
Okay.
Right. So yeah, we had a couple of different approaches that we tried out. We settled on, I believe it was just modulating the pulse width.
Okay.
The frequency is relatively low.
But constant frequency. You just have your PWM frequency and you stick to it.
Yep, that's it. And so yeah, it was interesting, to be able to do that, and to, very rewarding to have someone who functionally can't walk anymore, right? Helping them gain back some of that independence. And so,
well, I mean, the controls problem of being able to get like a human to balance seems incredibly arduous. I mean, I'm guessing their brain helps a lot in being able to pull that off.
Yeah, well, we a lot of the research early, what we were doing is we were just using a walker. So we were using a walker to help with the balance. But a lot of our research, right, we did as much as we could in simulation and testing things out in simulation before doing it on a person. And so to an extent, we are simulating, right, the walking dynamics. And so the same thing that all the bipedal robotics companies were focusing on in terms of what are the dynamics of it, how do I stabilize it, what's the control, which looks very different now, right? Back then, it was all very mathematical. Nowadays, when you look at, humanoid robotics, bipedal robotics, it's a lot of learned policies, right?
Oh, interesting.
So they're doing reinforcement learning, and you've got great platforms like the ones from NVIDIA where you can spawn out 10,000 bipedal robots over any number of random terrains with pretty accurate physics, and you can go and you can just say, learn how to walk, right? Here's your reward policy. You go figure it out, right? And then you're training this model.
Just throw a crap load of GPU at it.
Yep.
Yeah.
So, yeah, and we were using neural networks as part of my PhD research as well. We did neural networks for. Neural networks had were really well applied in control systems because it's adaptive controls. Right? Adaptive controls isn't anything new. And so we were using neural networks in these adaptive control schemes where you always have uncertainties in the dynamics or uncertainties in the parameters of what you're modeling. And so we were actually using neural networks to adapt to that uncertainty, right? And so there was some, maybe don't call it deep learning, but it's because it's adaptive control in the controls world. But we're using these neural networks as these adaptive controllers to compensate for, parametric uncertainty, disturbances, uncertainty, the dynamics of the system.
Probably even how the electrodes were seated on the skin, I would imagine, in some cases.
Right. I'm especially, working with electric motors is easy compared to working with human muscles. Yeah. It's so variable. And I mean, there's mathematical models for everything, all the way down to, what electrical impulse causes what activation of the muscle fibers, right? That's all been modeled and studied. And it's just interesting now because all of that work, right, developing all these advanced controllers and writing out all the equations of motion, right, pages and pages of math, and now you just stick it in a simulation and you run it for a day, and you have a trained policy on controlling a bipedal robot
with 10,000 instances all doing the same thing at once.
Right. Yeah, and I think it's hard. I think some people don't appreciate how quickly that has accelerated in the last couple of years. I think everybody appreciates how AI has accelerated in the last couple of years, but
sure.
One aspect that I feel like they don't appreciate.
Well, that's not like out in the in the public eye, right?
Right. Yeah, but one thing I think that they don't appreciate nearly as much is just the fact that how quickly you can train these models now. And so I think it was Agility Robotics did it recently at one of the trade shows where people were noticing that the robot was walking a little different, walking a little funny. And
Yeah, I think Mike Oitzman said it looked drunk.
Yeah. That's how I heard it. Obviously, I heard it from Mike Oitzman, because that's where you get all your news in the robotics world.
He's the best.
Yeah, and so listening to that podcast, and they're explaining that, and the big thing was, well, yeah, it looks funny. We just trained it yesterday. Like, it just learned how to walk yesterday, which is, people don't appreciate that years ago, right? You would spend days, months on supercomputers, right? Training up these models to be able to control a humanoid robot. And now they go and they're like, well, yeah, we trained it yesterday, right?
Looks a little drunk.
Yeah, it's like, it looks a little funny. It's not quite perfect, but we did it in a day.
Yeah, which is pretty damn impressive.
Right. And that's where I think, for systems like that, where they're going after these more generalized physical intelligence, right? One of the key things that they need to focus on to be competitive in that industry is how quickly they can train these models, right? How quickly can you train a humanoid to do a new task? Because they're going to have so many different tasks to do. And so how quickly can you get it to do that thing, right? A lot of people are really skeptical. I mean, I'm skeptical too, right? About, robots in the home.
Sure.
And imagine it trying to, do your dishes, make coffee, and all the different variables involved in that. But if you get the training time down to hours,
the hardware cost will still bankrupt you.
Yeah. I don't know how they're doing that. I'm surprised, because I think exoskeletons aren't too different from humanoids, right?
Right.
And
similar.
having worked on exoskeletons, I know how expensive it is. So same thing with humanoids, very expensive. So I don't know how they're getting the cost down that much, but that is very impressive.
Did you know that Collaborative with Spencer Krause now has a merch store? Please go to cwskmerch.com for the latest in CWSK styles. You can get a hoodie, like the one I'm wearing, t-shirts, hell, we even have whiskey glasses. Everything in the store has custom art that our team worked really, really hard on, so go ahead and show your support for them, me, and the rest of the CWSK team by going to cwskmerch.com today. Better yet, support yourself and use discount code PODCAST10, all one word, all uppercase, for 10% off your entire order. Thanks for your support and enjoy the rest of the show. With Spencer Krause is sponsored by SKA Robotics. If you're in the market for elite field robotics expertise, please consider hiring SKA Robotics. They sponsor this podcast and solve some of the toughest engineering problems in the world. SKA Robotics can be found at skarobotics.com.
So we got way off topic. The original question was the plan A and the plan B, right?
Right.
The plan A
was to
teaching.
teach. Yeah.
And so
the plan B was like, I guess I'll go into industry.
We went through the academia part of it, right? And so I got up to the point of doing my PhD, and my PhD advisor, he was new. So part of how I found that research with him doing neuroprosthetics was actually that he came to Pitt. He didn't have any students yet. And I said, hey, what I'm doing now for my master's, we're not going to get more money for it. So I need to find a new way to chase after that PhD. And here it is, right? So, and it, like, I'm fortunate that it was such a great subject to research, right? Neuroprosthetics and working with paraplegics and restoring motor function, really rewarding and exciting.
Yeah. Well, no, I'm cynical. I talk about third arms, but I actually did work on prosthetics back in like 2017, 2018, and it was one of the most rewarding projects I ever did.
Yeah. So I'm fortunate to have found myself in that situation, but then, I'm watching my academic advisor fighting for tenure, and I'm seeing other professors, the higher up you are, the more behind the scenes you are at the university. And so I'm seeing all these other professors fighting for tenure, people who are recognized as, great teachers, great researchers, they didn't get tenure, right? And usually it was because, I applied for funding and it just didn't come in, right? I didn't get it yet. And I mean, there was a professor at Pitt when I was there doing my PhD that he was up for tenure, didn't get it. And then shortly after that, like months after that, a month or two maybe, he got something like $10 million for the research that he was doing in nuclear power. And so obviously it was pretty easy for him to land on his feet when he didn't get tenure at Pitt, because he's walking to another university with a $10 million grant.
Yeah.
Right.
Hey, look what I brought for you.
Right. And so glad he landed on his feet, but like seeing people go through the tenure process and the struggle, and then hearing about everybody going through their postdoc and all the struggle with that.
So the tenured professor is like a profit center for the university.
Mm-hmm.
I didn't realize that. That's interesting.
Yeah. And so I just felt very frustrated with academia, and I mean even some of my research, right? You work on these hard, complex problems because they're hard and complex and novel, right? The goal sometimes is publications, and not always what is the greater impact, what is the good that you're providing.
Yeah, the publications
research.
seem to be the currency of the academic world from the outside looking in.
Right.
Yeah.
And so, I'm at Pitt working on using a variable gain super twisting sliding mode controller, right?
I know most of those words.
Yeah. So it's something very, very complex.
Wait, does that mean that your gains are changing on their own?
It's a little bit adaptive, yes. But
variable gain super twisting sliding mode controller.
Yeah.
What does super twisting mean?
The super twisting comes from how it converges to the sliding mode plane. So it's a mathematical thing, right? Where it's gonna, with sliding mode control, you're basically trying to get it onto a plane mathematically, right? And how it converges to that plane is this kind of twisting pattern.
Well, the plane is abstract, I'm assuming. So the result is probably solid controls, but somehow placing all of your gains on a plane gets you there.
Yeah, you're basically the sliding mode part essentially tries to drive you to that plane, a specific control plane. This is like 10 years ago, so I'm sure somebody's going to correct me on it. I'll have forgotten it. But the point of bringing it up, right, is that it is complex. It's mathematically complex, but it's novel, that no one had done that before, right? And so, you're in academia pursuing the novel problems, right? That eventually just seem like they're deviating from creating value for people, right? Where it's like, well, what I want to do here is I want to help people with motor disabilities, right? I want to help paraplegics walk again. Wouldn't that be great?
But is the method you did it with totally novel? You're like, well, who gives a fuck? Like, I just want it to work.
Right. And so, a combination of, feeling frustrated with the research that has to be novel, that has to be hard, and seeing everybody go through, the challenging tenure process, and seeing really great professors go through it and not get tenure, right? And just being like, well, even if you're good, you may not get it. And that sucks. And so I kind of decided, all right, well, maybe that's not for me. Maybe that's not what I want to do. I want to go out and I want to start to see some real world value of the work that I'm doing. And I just happened to get super lucky and ended up at Iam Robotics.
Nice.
And obviously, having talked to a lot of the people from Iam Robotics, you know how lucky I was.
You guys had a really good group there. I mean, I love Vlad. Obviously, I love Chris. I mean, you're the best. You guys had just a rock. Yush is amazing.
Yep. I mean, really grateful for ending up at Iam Robotics and learning from everybody there. And I definitely started to gain an appreciation for the business side of things as well, because I mean, you go to the trade shows and you talk to the customers, you understand what they're looking for, you do the deployments, right? You're not just the one that wrote the software, you're the deployment engineer. And so you're on the ground with the customer, you're understanding what's working, what isn't. And so I feel like definitely really helpful in kind of building an understanding of the business side of robotics.
Yeah, for sure. No, I mean, for me, like all of us went to college, right? And so, like for me, I feel like business, like I learned more in my first 6 months, like in business, than I did in like, between a master's and undergrad, 6 years of schooling. Yeah. And so, it's just, I don't know. Maybe this is me being a little bit idealistic, but I feel like it's like a total meritocracy. Like if you can make things work and just, like it doesn't matter how you got there, as long as, you just kind of keep your nose down and are able to kind of get it running. So
yeah. And so we had a lot of long nights of that, right, up in Rochester. Even deployments out to the Netherlands. Everybody worked really hard, and Iam Robotics is Onward Robotics now, and so I think I only know a few people left that are still there, and I hope they're doing well. So really want to see those guys succeed, but. Yeah, grateful for being there, learning from a lot of great people. And eventually, though, I was there for 6 years, and that's when, started thinking about, well, what's everything else out there like?
Before we move on from IAM, is there any way I can get the machetes and flamethrowers story from your perspective?
So
sorry, I know that's a little contrived.
It's okay, and I'm gonna try to fill in as many of the gaps, hopefully, as I can from the other people you've had on here that have told the same story. We talked about this before we started, right? That obviously I'm gonna try to skip some of the IAM stories, which are good ones. Because you've already had a lot of guests that have told the exact same stories, but since you ask about the machetes and the flamethrowers. So this was 2018 or 2019, somewhere around there, because we had moved out of the garage in Killbuck Township, and we were in this building by the river, close to Sewickley. So like right before you get into the bigger part of that, like downtown Sewickley. And the Pittsburgh Post-Gazette had called it a shack by the river. It was a little bit nicer than a shack by the river. So
the paper has a way of embellishing, I feel like.
So we weren't that bad off. It was a nice place. It was a big upgrade from the garage in Killbuck Township for sure. And so one of the really nice things about that building is that we were right on the river, right on the Ohio River, right?
Nice.
Beautiful. The problem, though, is that there's tons of trees and weeds and overgrowth. So, like, there's really nothing between us and that really beautiful river but all that overgrowth, right? And so, I think it was Jason Geist who kind of started, right, where he's like, oh, yeah, well, like, we can clear that out. I've got some machetes. I'll bring some machetes, right? And so Jason Geist one day shows up with a bag full of machetes, which just blew my mind. I think it blew everyone's mind, where it's like, Jason, why do you have a bag full of machetes? Like not 2-3 machetes, like a bag full of machetes, right?
And picturing 20 machetes.
Yeah. And so it's we all, kind of go out there, and it's, machetes and weed whackers clearing everything. I don't remember where the flamethrower exactly came in, but that was when Joel Reed came, and he's like, this is where I need to put my foot down, right? The machetes are okay. The bag full of machetes is acceptable workplace behavior. Flamethrowers is, that's not okay. Like, I'm going to have to stop you at flamethrowers.
Sounds like something Joel would say.
Yeah. And so, I mean, without the flamethrowers, we did manage to clear away everything, right? And had this great view of the river. Had a picnic table that we set out there, right? So I mean, you
sounds
can't,
lovely.
Yeah.
Couldn't have done it without machetes.
Yeah, you can't beat that, right? Is that you have you're working in a shack by the river with a bunch of really good friends, and you go out on nice days and you have lunch sitting at a table out by the river, right? Really nice.
Yeah, it sounds awesome.
Yep.
That is a different version of that story than I've heard before. I really enjoyed that.
So that is from my opinion. Like I said, I mean, I think everybody's going to have a different opinion on it, but you can piece it all together, and then eventually we'll just listen to the super playlist of
montage of just you and Yush and Joel and Chris all talking about it.
Machetes and flamethrowers. Yeah.
Yep.
Yeah. I mean, if Elon Musk is going to allow people to have flamethrowers at SpaceX, why not flamethrowers at Iam Robotics? I just
there's
don't
the
get
Boring Company flamethrower, right?
Right, right. Oh, that's right. It was the Boring Company, not SpaceX. It was the Boring Company.
But they made one. Yeah, they just had a flamethrower.
Yeah. So, but yeah. So yeah, that's the Iam story, and I think so. We were in that building until just a little bit pre-pandemic. Moved down into Lawrenceville.
That's the location that's still in.
Yep, robotics row, right?
So I shouldn't roll my eyes at robotics.
I had a really nice warehouse down there. Have right. I'm talking in the past tense because I was there. I'm not there anymore, but they still have that location. I landed on my feet. I went to Omnicell where I'm at now, and so I think they have such a really amazing vision, right? The autonomous pharmacy, and it's this whole concept of, if you are a highly skilled healthcare professional, there are a lot of tasks that you do today that you should not be doing, right? And so they're really working hard to automate a lot of these, manual processes that are being done in the pharmacies and in the hospitals today. Inventory management is a big part of that, right? Managing your medications, managing your supplies is a really big part of it. And one of the examples that I've used a few times, and I didn't know how prevalent it was, right, is that if you go to school to be a pharmacist, if you go to get a PharmD, right, you're probably spending a few extra years in college and maybe, around $100,000 extra in debt, right? Do you want to be working in the basement of a hospital counting pills all day?
Not if I can help it.
Right. And so, and do you think that there's technology out there that means you shouldn't have to do that?
Nah, it'll never work.
Right. And so, but that's where it's like, the technology exists that we can alleviate a lot of these manual tasks that they do today, right? These pharmacists shouldn't be counting pills down in the basement, right? Computer vision is now at a point where you can count pills very quickly. You can identify the types of medications, right? It's a lot of the technologies are there, and so it's a company with a really strong vision for sure, right? And a really positive one because there's such a shortage in healthcare professionals, and Omnicell has a means to basically help alleviate that pain, right? We're definitely not addressing the labor shortage, right? We can't make more people go into the healthcare profession, but we can definitely help the people that are there by using, technology in a lot of different ways.
It's a force multiplier.
Right. And so, yeah, Omnicell is an interesting company, especially in Pittsburgh, because Omnicell, the group that is here in Pittsburgh, wasn't always Omnicell. It was
Automated Healthcare, I think.
It was originally Automated Healthcare, yeah. So 30 plus years ago, it was Automated Healthcare, which was one of those CMU robotics companies, right? And Automated Healthcare was acquired by McKesson, was divested, and it became Ascent. And then Ascent was acquired by Omnicell about a decade ago, I think. And so, some of the people at Omnicell today working in that Pittsburgh office, I mean, they've been working at this problem and in this industry for 15, 20 years, right? And so their industry expertise...
That's like 70 years in robot years.
Yeah. Yeah. So they like really phenomenal industry expertise. And so... and that, I mean, that's the Pittsburgh office. It's the same thing. Omnicell itself was started up in, Silicon Valley, also 30 years ago, starting with medication storage solutions and then kind of growing out from there.
Very
So
cool.
both sides of the organization have a pretty deep history in healthcare.
Yeah, it's awesome. Well, I mean, I agree, right? Like, it's really cool just to see, robots helping people with jobs that can be mundane or, error prone. I mean, if you screw up a pill count, that kind of sucks.
Oh, yeah.
Having to count pills 3 times in a row to avoid. I don't know if it's 3 times, but I think you have to double count as a pharmacist. Is my understanding.
Yeah, and it's the same.
Tech, yeah.
It's the same thing with IV compounding, right? That
I would imagine it's worse because you can't really tell.
It is. Yeah, it is worse. Obviously with pills, it's kind of the same thing, right? One blue pill looks like other blue pills, right? And so it is kind of hard to differentiate them sometimes, but a clear saline bag looks a whole lot like a clear saline bag with a bunch of clear medications that have been injected into it. And so the usual workflow for compounding IVs, right? You usually have 2 people working that job because you need one person doing the work, one person, creating records and verifying it. And so you might have a pharmacy tech making the IV bag by hand, but a pharmacist ultimately signs off on the IV bag.
Yeah.
And so
labor intensive to make an IV bag.
Yeah, really, really labor intensive. And that's why they, Omnicell came up with solutions like the IV workflow, which does use computer vision and gravimetrics to, automate out a lot of the process of checking the medications and working you through the process of compounding an IV bag. Right, it's gonna pre-weigh the medication, post-weigh the medication to make sure that you're actually putting the right amount of medication in that IV bag. It's taking pictures of everything, right? It can record everything, it can save everything up to the cloud, which is like a huge advantage of automation, right? Is that all that process of, if I was the pharmacist checking someone's work and I'm writing it all down, right? Even if I'm putting it in a computer, right? There's a lot of manual work involved with it. Right, somebody reads a number off a scale to me. I'm going to type it in, right? They draw the medication, they measure it on the scale again. They're going to read it off to me. I'm going to type it in, right? With a computer, it just happens in an instant, right?
Yep.
It reads the number, it logs it off, and you're done. And so, yeah, IV workflow is kind of the first step up to it, where now one person can do it. You have sufficient checks in place that it's kind of signing off for you. And then you've got the IV station, which is fully autonomously compounding IV bags. You do have to feed it the raw materials, right? So your syringes, your vials of medications, your IV bags, but it's going to use a robot arm and go through that process of compounding those bags for you. So as a pharmacist, right, you just tell it what you want for the day. You set it up with all of the materials to make it. And then you go and you maybe you're going to make some IVs that are harder to make, right, for automation. Maybe you're dealing with specialized medications, and so they're hard. It's harder to automate some types of medications, like really viscous medications. And so
that's interesting. I guess that makes sense.
Mm-hmm. Yeah. So yeah, there are certain ones.
Viscous medications in an IV though, like how does that work?
Well, it's more of a challenge when you're drawing them from the vial into the syringe.
Oh, I see. So it's not like you're hanging it in an IV bag; it's going in a syringe and getting injected.
Yeah,
that makes more sense.
Yep. Yeah, they all end up in the IV bag, and then the IV bag makes its way up to a patient, right? But you've got this full process of either automated with the station or semi-automated workflows with the IV workflow. You're printing out these labels, you're verifying medications, you've got a full record of all the work that went into it, which is really cool. That's the whole career. And like I said, the original plan was teaching.
I'm glad you didn't do that. I shouldn't say it like that, but I'm happy that you're in industry.
The way I look at it is that I feel like I didn't abandon that completely, because I still found a way to teach, just not through the traditional means of teaching through academia, right? That to me, being a manager, being a mentor, being a coach, right? Career coaching.
Yeah.
That's teaching, right?
That is true.
Yep. And so to me, it's, I still find a way to do it. It's just not, it's just not, I'm not going to be labeled as a teacher. I'm going to be labeled as a engineering manager,
Right.
Right.
But you're still teaching people stuff and,
Yeah.
listening to people's problems, and you're a psychologist, a lot of the time.
Yeah, it doesn't change my mindset and my approach to it. Not a psychologist, right? That's my wife. That's her business.
Fair enough.
She deals with the brains. I deal with the technology.
You don't think at some level though, like every engineering manager is like a little bit of like you have to understand people's problems and.
Yeah, and so one of the books that I really enjoyed reading, and this is something that I got into when I was at Iam Robotics, is a book called Surrounded by Idiots.
Oh, that's a great book.
Yeah, and so
the color-coded people.
Right, and so obviously they present essentially psychology in a really dumbed down way, and so I brought that to my wife, who is a psychologist, right? A doctorate in psychology, and I talked to her.
She's a developmental psychologist.
Yeah, and so it's like, what do you think about this, right? And it's like, well, that's just the dumbed down version of psychology. And it's like, well, yeah, but for people that don't have a doctorate in psychology, for people that are working for a living and have to work with people, it's a good way to communicate, how different people have different approaches to problems. And it's a good way to understand that you can accept that somebody's going to do something a different way from you. And that's fine. That's okay. That's their approach. There's pros and cons to everybody's approach, right? It's just a matter of kind of making it all work.
When she says dumb down, does she mean because like they just bucket people into those 4 categories?
Oh yeah.
I mean, there's a lot more nuance than that, and there's
yes.
overlap, and
Yeah. So like the DSM-5 is a giant book, right?
Right.
And to dumb it down to but people are just 4 colors.
It's just 4 different colors of people.
Yeah.
I mean, I think the Sandler selling system does the same thing. Like they've got the DISC method, and it's like it's the same exact categories as Surrounded by Idiots, but it's just different letters for them.
Yeah. He and I think he explicitly says that in the book, that it's essentially the DISC method. But I feel like I got into a lot of books like that, Surrounded by Idiots, and How to Win Friends and Influence People.
Oh, that's a great book.
Yeah, Dale Carnegie.
I got to reread that. I feel like I've forgotten a lot of the important parts.
The dumbed down psychology books for people that don't have a degree in psychology.
Like Influence, the Psychology of Persuasion.
Yeah, and so it's it's interesting to read those, and to me it was all just about kind of understanding different people's perspectives.
Yeah.
So, because I think, again, like within robotics, what a lot of people don't understand about robotics is that you're going to spend a whole lot of time working with people.
Oh, 100%.
For being I want to work on tech and I want to sit in front of my computer and code all day, right? You're going to work with a lot of people, and people like...
I mean, that's most of the job when you're managing.
Exactly. Yeah. When you
understanding people's motivations.
Right.
Like,
when you're managing, for sure. But I mean, even when you're an individual contributor, the best employees from the perspective of a technology, hardware, software company are the ones that can kind of cross that border between hardware, software, right? They're able to communicate well because the hardware and the software are coupled, right? No matter
100%.
No matter what you try to do.
Well, and the hardware is further decoupled into mechanical and electrical, and then systems engineering is like the umbrella over all of it, and then it's all interconnected. And,
right. And so you just kind of you take the robotics org chart and you break it down, and you say, okay, we're going to have electrical engineers, mechanical engineers, software developers. I'm going to break software developers down to low-level embedded engineers, right?
Which some people would call hardware developers.
Yeah. Higher-level autonomy engineers, right? Computer vision, all those different disciplines.
Perception, navigation.
All the different disciplines within, like, what you would lump in as software, right? And then you start breaking into as well systems engineers and product managers and project managers, and that you work with so many different people from so many different parts of the org chart, but you really all just have the one goal.
Right.
And your ability to work together towards that one goal determines how good of a job you're going to do at it, right? Whether or not you're going to be successful.
Yeah, for sure.
You've got to work with people outside of engineering, right, work with the rest of the organization to understand the bigger picture, and then bring that into your day-to-day activities to say, the thing I'm doing today is small, right? But it is a step in the direction of what we want it to be, right? It will inevitably contribute to the value of this product that we're building.
Right, 100%.
So
awesome. I feel like that's a perfect note to end on. Like, that is unifying. It's a great message, and I think I'm going to call it. So on that note, is there anything you want to plug on your way out of the podcast?
Obviously, I do act as a career coach. I try to help people out. It is hard to get into the robotics industry. I think partially because there are just not as many opportunities as there are in other industries. Robotics is still pretty small. So I'm always happy to help people out, right? So if anybody ever wants to reach out, happy to try to help in any way that I can.
What's the best way to get a hold of you for that?
Yeah, LinkedIn is great. Nicholas Kirsch on LinkedIn. The sad thing is that I'm not the only Nicholas Kirsch on LinkedIn. So you're going to have to look for the one that works for Omnicell, or you can find me at, roboticscareercoach.com.
Nice. That's a great domain name.
Yeah, thank you.
You're welcome.
Simple, straight to the point. I'll thank, shout out to Jess Peterson, who, helped me and guided me with some of the career coaching work.
Yeah.
But yeah, the point of that is to just kind of help people transition into these new careers, with these new technologies. And the point of mentioning that I'm not the only Nicholas Kirsch on LinkedIn is that when I finished my PhD working on neuroprosthetics, I found that I am not the best Nicholas Kirsch PhD at the research that I was doing.
Wait, what?
So if you look up like Nicholas Kirsch, maybe Nicholas Kirsch neuroprosthetics.
There's another Nicholas Kirsch in neuroprosthetics.
It will not be me. And I think he's got an extra 20 years on me. So he's got me beat for sure. And so, right, he's got more publications, more citations, and it's like, well, great. No one's ever going to find me now. So, yeah, not Nicholas J. Kirsch. That's the other Nicholas. Well, one of the other. There are more.
That's hilarious.
Yep.
All right, so roboticscareercoach.com.
Yeah. Yep. Or LinkedIn. Like I said, just make sure it's the one at Omnicell, right?
Nice. All right. Well, Nicholas, appreciate you coming on. You're the best.
Yeah. Thank you for having me. I had a great time.
We'll have to do it again soon.
Yeah. Sounds good. Thank you.
Thanks for joining us today. If you've made it this far, chances are you'll like other episodes too. Collaborative with Spencer Krause can be found on YouTube, Google Podcasts, Spotify, Apple Podcasts, Pocket Casts, and Radio Public. Subscribe today to get notified when the latest episodes release and support the channel. Collaborative with Spencer Krause is sponsored by SKA Robotics. If you're in the market for elite field robotics expertise, please consider hiring SKA Robotics. They sponsor this podcast and solve some of the toughest engineering problems in the world. SKA Robotics can be found at skarobotics.com.